Hey everybody, today we'll be learning about our first classification model, which is logistic regression. Now, don't let the name fool you. It is a technique for classification, not regression. So, just to remind you, regression was a technique where the outcome variable is continuous. So, for example, you had features such as the size of the house, the number of floors in the house, the area of the house, and so on. And the output was the value of that house, for example, 1 million or 1.7 million. Whereas logistic regression is used for classification where the outcome is discrete. So, for example, given a certain set of features, you can say whether the image is a cat or whether the image is a dog, and so on. So, what is the main objective of logistic regression? Well, the main objective is to learn the probability of y given x, where y represents the class, whether it be a dog or a cat, and x represents our features. Now, in logistic regression, we assume that the probability of y given x takes a functional form. In this case, it will take the form of sigmoid. Now, sigmoid function has some cool properties. So you can see it's bounded between 0 and 1. Now, as the value increases, the value converges to 1, while as the value decreases, it converges to 0. So let's have a deeper look at how logistic regression works in a binary case, meaning that you only have two classes, 0 and 1. So the formulas you can see are the probabilities of a sample belonging to either class 0 or class 1. To get the probability that the sample belongs to class 0, we can just do 1 minus the probability that the sample belongs to class 1, and you get that corresponding formula. Now, if you look closely, you will see the similarity between linear regression and logistic regression. The input to the sigmoid function is bias plus omega 0 x 0 plus omega 1 x 1 and so on, which was the equation that we used to predict the outcome in linear regression. In logistic regression, we just give that equation as input to the sigmoid function to get probabilities. Now, based on those probabilities of each class, given a set of features, we assign that sample to the class with higher probability. The result is a linear line separating your samples as shown in the figure on the right side. So what are we trying to optimize in logistic regression? Well, we're basically trying to reduce the log loss, which is minus y log y dash minus 1 minus y log 1 minus y dash. Now, y represents our 2 class and y dash represents our probabilities, predicted probabilities. Now, this loss function is basically a concave function if we want to use gradient ascent to solve the problem, or a convex function if we want to use gradient descent to solve the problem. Now, what that means is basically you can think of a loss function as this convex figure. And what we're trying to do is at each point, we take the gradient of that point and we update the weights or the parameters of logistic regression. And we move towards the opposite direction of the gradient to get to the minimum point. And that minimum point would be our solution to the logistic regression. So in logistic regression, in gradient descent, when we are trying to optimize the log loss, we need to take care of the step size. If we keep the step size too big, then chances are that uh, it will keep oscillating and would not converge to the minimum. Whereas if you keep it too low, then it will take forever to reach the minimum. So we have to make sure that the learning rate or the step size is big enough, but not too big. So today we'll be implementing a customer churn prediction model. So we'll be exploring binary classification using logistic regression, where our output would be whether a customer would leave us or not. So we will have multiple variables to determine whether the customer is going to churn or not. And this can help us in various things, like if there's a high probability that a customer is about to leave, then we can try to mitigate the problem and try to make sure that the customer doesn't leave us. So the data set that we're going to be using can be found in the link below. And you can also use the following command on your Jupyter notebooks, which is wget and the link to the CSV file. So the first step is we're going to be importing certain libraries, and we're just going to read the CSV file that we downloaded from the link. And we're just going to look at the shape of our data. So we have 7,043 samples and we have about 20 features. and you can see certain features. So we have gender, we have senior citizen, whether the customer is senior citizen or not. We have the tenure, we have internet service, what kind of internet service they're using, and so on. So here we are just checking the features and what their data type is. So if you see something called object, that means that that particular column represents strings. Integer represents integers and float represents float. So we can see most of our features are in the object format, whereas we have some that are in integer format. So what we will be doing next is we'll be cleaning up these features before we apply logistic regression to our data. Before we move on to the cleaning part, we also check for null values. So null values are missing values in our data, and we can see there are no missing values in our data. So that's good news for us. So here we'll be learning how to deal with categorical features or features that are represented by strings. Now, machine learning models directly cannot work with strings. So what we do is we convert those strings into a representation that would allow machine learning models to learn properly from the data. For that, what we do is we convert the strings into numbers. So there are multiple ways to do that. Here we're going to be talking about two ways. One of them is called label encoding, and the other one is called one-hot encoding. So in label encoding, what we do is for each particular unique value of our feature, we give it a unique number. So for example, red became 0, green became 1, blue became 2, and so on. For one-hot encoding, for each of the unique features, we convert them into separate columns, and each column will have the value 0 or 1, where 0 represents that that particular feature has that particular value. So in our case, for example, for the first sample, the color is red, so our output is red 1, yellow 0, green 0, because the feature is red. Similarly, for yellow it will be 0 1 0, and for green it will be 0 0 1. So that's one way how we can deal with categorical features. So now that we know how to deal with categorical features, we are going to start cleaning our data. So the first step is to convert the column contract and use a label encoder to convert the unique values of that column into numbers. So firstly, we will import the label encoder from sklearn.preprocessing, and then we will call the label encoder function .fit transform and give the column contract values as input. Now this will convert all the unique values of the column contract into numbers. We also have some columns that have redundant information, so we are basically going to clean them up using some lambda functions. What we end up with is only like two unique values for each of these columns. Finally, we can start converting the strings into 0 and 1. So for example, in gender column, we convert male to 1 and female to 0. For payment method column, we convert the checks to 0 and the other payment method to 1, and so on. So we still have some more cleaning to do. So what we are doing is for the remaining columns, we are going to convert the value no or 0 to 0, otherwise 1. For the column date total charges, there is actually an AND, but since it was seen as a string, we were not able to see it when we use the command .isNA.sum. So just to avoid any problems later on, we're just gonna drop that particular row, and we're just gonna convert the whole column into float using as type float. Now, just to double check our data, we will again have a look at the D type or the information that is stored in each column. And apart from our customer ID, you can see all the remaining columns have either integer or float stored, which is great news for us. We can ignore customer ID since it won't give us any useful information. Each customer would have a unique ID, which doesn't help the machine learning model in any way. So before we move on to implementing our logistic regression model, let's have a look at our class distribution. So if you look at the plot, we see that the class 0 or the customers who have not churned are about 5,000, whereas class 1 or the customers who have churned are about 1,800. So the number of samples belonging to class 0 are way higher than class 1. Now, this problem is called imbalanced dataset or class imbalance, where the number of samples for a particular class is much higher than the other class. And we will have to somewhat tweak our model so that it keeps that into account. So before we start with splitting our data into training and test, a good thing is always to plot the correlation matrix to see the correlation between your features. If a few features are highly correlated, you can just take one of them and ignore the other. So in our case, we're just going to drop monthly charges and tenure. And we're also going to drop customer ID because it does not have any useful information for us. And after that, we're going to start with our machine learning process. So like I mentioned in linear regression, the steps that we will follow to create our logistic regression model will be more or less the same. So the first step is we will define our features and our target variable. So our y represents whether the customer is going to churn or not, whereas our x represents the features. So the step two would be splitting your data into training and test. So we are going to call the train test split function, and we are going to save 25% of our data as test and 75% as training. The third step is to import your model. In this case, we will use logistic regression. Now you see logistic regression here has certain parameters. Now C equals 10 is basically the penalty, and the class weight is balanced. Now this particular parameter in logistic regression called class weight, this represents the number of samples for each class, and we can use equals balanced when we have a data set that has a class imbalance problem. After that, what we do is just train our model using the fit function. We call the predict function to predict the output for each of our test samples. And then we just check our performance. So here we are going to import the metrics and we're going to print the classification report. Now, if you have a look at the classification report, it will print out the precision, the recall, and the F1 score for each of the class 0 and class 1. So we already saw the precision and recall for each of the class 0 and class 1. Now let's also have a look at the confusion matrix. Now this confusion matrix will show us the number of times we have predicted class 0 properly and then class 1 properly, and the number of times we have not predicted them properly and we made a mistake. To do that, we will just use the crosstab function, give two inputs, which is our y test and our predictions, and just give the names for our rows and columns. And as you can see, overall we had about 1758 samples in our test data, out of which for class 0, we predicted 909 of them correctly, but 394 of them were predicted incorrectly. Overall, we had 1,303 samples for class 0. And for class 1, which is what we are more interested in, which is the number of customers who are likely to leave or have or will leave, 87 of them were predicted wrongly, while 368 of them were predicted correctly. So if you remember, we set the C value to be 10, and then we just trained our logistic regression model. What if we want to make sure that we find the correct value of C such that we get the best model? Or which kind of penalty or regularization should we use? Should we use L1? Should we use L2? Should we use class weight to be balanced, or should we not care about the class imbalance in our data? To solve such problems, we can call the grid search CV method. Basically, what we are trying to do is we give a range of parameters of our model. And what it will do is, like, for each of those combination of parameters, it's going to train a model and give you the best model with the best parameters. So what we do is we call our model. So here we are again using logistic regression. Liblinear is basically the way we solve the logistic regression problem. So here we give a dictionary with certain parameters. So for example, we can experiment with the penalty L1 or L2. We can give C different values, 0.01, zero 0.1, zero 0.1, and so on. We can see whether we want to give the bias or not. And we can also double check whether we want to balance the class weight or not. Now, based on these parameters, We can call the grid search CV function, which is going to use cross validation, and the scoring, which is basically the metric that we are using to find the best model. In this case, we are using AUROC, but you can use precision, you can use recall, whichever metric you want to optimize. And then we just fit our X train and Y train on this GS function. And what the output would be is the model with the best parameters that gives the best results on our training set. So once we have run our grid CV search, all we need to do is extract the parameters of the best model that gave the best results in terms of AUROC. To do that, all we need to do is call gs.best underscore estimator underscore. And what this does is it copies the parameters that give the best results into this new variable called best underscore model. Then what we do is the same process. We train this model on our training set and then predict on the test data and then check our performance. So one thing you should be careful about here is which metric would you like to optimize? Based on different applications, you might want to optimize precision or you might want to optimize recall. In our case, since we are working with customer churn prediction, we would like to optimize the recall for class one. Why is that? It's because we really want to make sure that the customers who are likely to leave are predicted properly so that the company can do something about them. Now, based on different applications, you might want to you might want to optimize precision, for example, in recommendation systems, where you want to precisely recommend something that the user would like, and so on. So, always be mindful about the metric that you want to optimize. So, what's our conclusion on logistic regression? Well, the output of logistic regression is basically probabilities of success or failure. In this exercise, we were basically predicting the probability whether a customer will churn or will not churn. The output is a linear combination of independent variables. So we can always use a threshold to define an answer based on a probability. And the decision boundary is a linear boundary between classes in the feature space. When should we use logistic regression? Well, the best to use logistic regression is when you have small data, whereas if the data has a lot of features, it might not be the best model to use. And the other thing we should be careful about is if the data is linearly separable or not. Now, in cases where the data is not linearly separable, linear regression would perform quite badly. Finally, let's come to the advantages and disadvantages of logistic regression. Well, the advantages is it is very easy to implement and it acts as a very good baseline. Also, it is not heavily affected by highly correlated features, which might be a problem for some other machine learning models. The disadvantage is it is susceptible to noise. So if our data has some noise in it or it's a little bit corrupt, that will hugely affect our logistic regression model. And also, if the dimensions or if the number of features that we have in our data set increase, our accuracy of logistic regression model most likely will decrease.